So 2-4 is on exact equations. So exact equations. Exact equations. Exact equations. So I guess even before I use my notes, let me just go over some stuff with you. So here's an example. So say we have a function f of xy. So this is a function of two variables. Normally we just have f of x, right? So normally we have like y equals f of x. So y is the output, x is the input. Here x and y is the input, and you can think of this as z. This is equal to z, right? This is like z. I'll erase it, but you can leave it. Z equals this, but I'm going to erase it. Okay. So x, y are the input, z is the output. Okay, let's make one up. Say we have x squared, y squared, plus x cubed, plus y to the fourth, y to the fourth. This is a multivariable function, they call it, or a multivariate function, if you want to sound even fancier, or even more old school, a function of several variables, right? It's a function of two. I have a book called Calculus of Several Variables. That's like the name of the book. Yeah, it's a pretty cool book. Right, okay, so normally we find the derivative, that's dy dx, right? That's the rate of change of y with respect to x. That's the slope of the tangent line. So now we're going to find something else. It's called the partial derivative. So the new symbol, it looks like this. Del, del, del. So it's del f, del x. This is called the partial derivative of f with respect to x. And what it does is, it gives you the rate of change of f in the x direction, right? Because remember, it's in 3D now. So how do you do it? It's really easy. Basically, when you do this, you pretend all of your y values are constants. All your y's are constants. So this is like a number, so it hangs out. It's like 4. So you just take this derivative with respect to x. So 2x, and the number hangs out. It's just like a number. It just hangs out, right? If it was a 4, it would just stay there. It's like a number. This is just x cubed, so just a regular derivative, so 3x squared. 3x squared. And then this one's a number, so what is the derivative of a number? 0, very good. I'm going to leave the 0 there just so you know when you go home, if you look at your notes, that you know it's 0. So when you take the partial derivative of a function with respect to x, all of the other variables are constant, right? All of them. Let's do del f del y. This is the rate of change of the function in the y direction, right? In the y direction. So now all of the x's are constants. So x squared is like a number, right? It's like a number. So it'll be 2y x squared. 2y x squared. You do this in Calc 3, but it's not until like your third test, depending on what school and all that stuff. Oh, I almost got confused. I was looking here. Losing points. No, not today. What's the derivative of x cubed? 0. Very good, because it's a constant, right? It's a constant. So it vanishes. I wanted to use that word. Yeah, a lot of the old school math books say stuff like that. The second term vanishes. Like, whoa, like it's like magic. Like you picture smoke coming out of the pages. And then this one will be 4y cubed. I had a friend who used to think that mathematicians were magicians. He would always write math magicians on the board. Yeah, he had a breakdown. So here we have 2y. No, he did. I don't know what happened. Middle of a test, he took the test, he crumbled it up, and he slammed it in the trash, and he walked out. I never saw him again. I know. He just couldn't handle all the math classes.
Maybe he said mathematicians aren't magicians.
Yeah, I don't know. Every time I think of vanishes, I think of him, because he used to like hang out in the study room, like, hey, all right, guys. And then one day he couldn't take it. Any questions on this? That's really sad, right? His name was Adam, but okay. All right. Let's talk a little bit more about other stuff. So some new stuff. We'll come back to this. We'll get more practice with this. So let z equal f of xy. So let z equal f of xy. Okay. We're going to define something new. So then we're going to define a new creation, a new construction. We're going to call it dz. So then dz, it's going to be del f del x. This is also something you see in Calc 3, but later in the course, plus del f del y dy. This new creation, we're making this up. This is a definition. And this is called the total differential of the function, or total derivative. Is the, I'll explain what it's for and stuff. The total differential, it's just a little bit of theory, and then we can do the problems. The problems only take like 5 minutes once you know how to do it. It's like, boom. Total differential of z equals f of x, y. Let me pause here. It's also called the total derivative. Take your time. We got time. Yeah. In my night class, I think we had exactly 45 minutes, and well, we only had 40. I checked, and we ended up doing 3 problems. So as long as we can do 2 problems, I think we'll be good. Because they're all the same. So that's called the total differential of a function. Yes?
You can write this in a different way, right?
What do you mean? Maybe? Like, no, maybe.
I think it's d over dc equals.
Oh, sorry.
Dx over dz. Can you write it like that? Or no?
Dx, no. You could probably, you could rearrange stuff maybe. Yeah, did you see this in Calc 3?
Yeah, but I think you wrote it differently.
Yeah, maybe. Probably there's other ways of doing it, but I don't recall. Good. What's your name?
Cass.
What is it?
Cass.
Cass. Okay, I was not going to say that. Okay. So check this out, Cass, or anyone else. Just watch this. So if z equals, let me look at my notes. If z, oh no. Okay, sorry. If If z is constant. So id est. So in other words, f of x, y is constant. So if z is constant, that means f of x, y is constant. So if it's equal to a constant, right? So you get the same constant. No matter what x and y you plug in, you get the same constant. Like a circle, like x squared plus y squared equals 4. That could be 4. Then dz is 0. Right? Then dz is 0. So if this is equal to a constant, then dz is equal to 0, right? Because the dz is the derivative of z. So what does that mean? That means that you end up with the following. You end up with del f del x dx. I'm going to write it again. And I'll explain what this is. I forgot to explain it. And then this is equal to 0. So this is a dE. Let me put that in a box. This is a dE. This is a dE. Right? This is a differential equation. Right? This is a PDE. This is a partial differential equation, right? So this is a differential equation involving an unknown function f and its partial derivative. So we're actually going to be solving partial differential equations when you think about it. No one ever thinks of it that way, but it is, right? I mean, it is. I don't even think it says that in the book. But, I mean, that's the definition of a PDE, right? So we have the partial derivative of f with respect to x dx, partial derivative of f with respect to y, then dy, and equal to 0. So it is a PDE. It is a PDE. What is this for? You can use this in Calc 3 to, one thing you can use it for is approximations. You can think of del f del x as the rate of change in the x direction. And then dx, you can think of this as a small change in the x. So this is the rate of change in the x direction times a small movement in the x direction. The rate of change in the y direction times a small movement in the y direction is equal to a small movement in the z direction. So you can use this to approximate the change in z. So dz approximates delta z, the actual change in z. Yes, Tony?
These were primarily used for vectors, right? The partials.
These?
Yeah, just in general. Like when you have I hat, j hat.
Yeah, yes, most of the time. Yeah, we can use them that way. Yes. So basically, we have a DE. So we can create a DE. Let's do a simple example. So you see, just so you get more practice. Say we have x squared minus 5xy plus y cubed equals c. Say we have this, and let's find dz. Find dz.
That's 5xy? That's minus 5xy?
Yeah, sorry, minus 5xy plus y cubed, yes. So x squared minus 5xy plus y cubed equals c, and we're going to find d. Just for practice, just to give you more practice with this. And then it illustrates a key point too. Okay, solution. So dz is just this, right? It's just this formula. I think we should just do it. This is dE. We got this. We can do it. So I'll write the formula down, I guess. So it's del f del x dx plus del f del y dy. That's going to be dz, right? But c is equal to 0. C is equal to a constant, sorry. So dz is equal to 0. I misspoke. So this is equal to 0, right? Because dz is 0. You can think of this as your f of xy. So f of xy equals a constant. That's the idea. And it's a little bit different than what you're used to in normal math, right? Who here hasn't had Calc 3? Just curious. Quite a few people. Okay. Okay. Oh, you're taking it. Oh, you're in my class. Yeah. Yeah, we haven't had a class in like forever because of the holiday. Okay. So del f del x. So it'll be 2x. So 2x. 2x. And then here we have to find the derivative with respect to x. What would that be? Anyone know in this case? 5y. Negative 5y. Very good, Trent. Because the derivative of x is 1, right? So it'll be minus 5y. And this would be 0, right? This is 0 because it's a constant. So dx plus. And now we got to do del f del y. So this will be 0, right? That one's 0. So it's 0. So parentheses. This will be minus 5x, right? Because the derivative of y is 1, right? So it's minus 5x. I really had to think there. Like, that was hard. Minus 5, because take the derivative with respect to y, that's 1, right? This is a constant. Plus 3y squared dy. And the whole thing is equal to 0. Equal to 0, running out of room. You know, I should just do this. There we go. Just use the metal. That's it. So that's the total differential, right? That's the total differential. So given a function, we created a differential equation, right? So if someone gives you this is a function, f of x, y equals c. So given a function, we created a dE. Everyone okay with the math here? So again, it's 2x minus 5y, because the derivative of x is 1. This derivative is 0. And then now del f del y would be 0, so I didn't write it. With respect to y, it'd be minus 5x, 3y squared, and then dz is equal to 0, so it looks okay. So given a function, we created a dE. Right? We're making up differential equations. So the natural question is, if you see this, can you go backwards and find the function, which is the answer? So this is a solution to this dE. This function, this is the answer to this differential equation, right? Because if you plug this into this, you get 0 and it checks, right? If you take the total differential of this, so it's weird because your answer is always equal to c. So the reason I'm going through this is just so you have some kind of, even just a little bit of understanding that the answer always has this form, which is a little bit weird. Okay, so can we go backwards? Well, sometimes. So now there's a definition and a little bit of theory, and then we'll do a problem. So let me just give you the definition. It's kind of a really technical definition, but it's beautiful. It's really cool, and it's good to learn stuff. So def. Def means definition. I'm just saving a few seconds by writing def. Right. Okay. So we say m dx. So we say m dx plus n dy. So m here is a function of two variables. I should have just written it. M of xy, n of xy. This is like your m here. This would be your m, and this would be your n, right? M, n. Okay. So we say m dx plus n dy is an exact differential. Is an exact differential. Okay, is an exact differential if it corresponds to the differential of some function. So in other words, if there's a function whose total differential is this. So like this one is an exact differential, right? Because the total differential is this. So if we can find a function. So if it corresponds to the differential, it's a lot of writing, but it's good for us, of some function. Maybe you'll look at your notes in 10 years. Who knows? To the differential of some. Do you all keep your notes forever? Yeah. I used to. I do. Some. I burned a whole bunch of them a few weeks ago. Months ago, last year. I built a big fire in the front yard and just set it ablaze. But I kept a lot of them. I burned some that I'm having regrets about too. Like there was some good ones there that, yeah. A lot of old tests too, student tests. Like 2015, I'm like, oh yeah, oh Kimberly, oh Joey. Final exams. Yeah. If only they knew, right? I'm sitting there just. Okay, so in this case, fire's fun. In this case, especially because it's cold now, in this case, this equation, mdx plus ndy equals 0, is an exact equation. So exact equations are basically equations that we can solve using this, right? In other words, so this is an exact equation, right? This is because this is the total differential of this function, right? So they're not all exact, right? If I just make it up, it might not be exact. If I just write down whatever on the board, it's not exact, right? So there's a way to tell. So if you're taking a test and you see something like this, there's something you have to do in order to check to see if it's exact. If it's exact, it's super easy to solve it because I'm going to show you the easy way. It's really cheap. I don't like it, but it works. And it gives you the answer in 10 seconds, a minute.
Equals 0 for the top one?
No, we don't. No, I know. I wanted to do it, but I was like, no, let me just stick to no, this is just, when it's not equal to 0, it's just called an exact differential. When you set it equal to 0, it's called an exact equation. Subtle difference. But I had to be correct because it's a classroom. Yeah. But yeah, see the difference though? This one's an equation, this one's not. That's the only difference. So here's the test. Here's the big test. And then after this, we can do a DE, right? We'll do a DE. So it's a theorem. Let's put THM, theorem. So there's some assumption which is worth going over. So suppose, I'll even spell it. Suppose M and N are, and here's something you've never seen, so I'll use it as an opportunity to show you some extra stuff. It's a new word, okay? Continuously differentiable. The book uses this language, but I don't believe they explain what it is. So let me pause here. In some rectangle. So in some rectangle. So the proof is done in a rectangle in the plane. Not a disk, a rectangle. Usually things are done in disks in 2 dimensions. And let me pause here. So you see the word continuous and you see the word differentiable. So you're like, what could that be? It basically means that the first partial derivatives of m and n are continuous. So this means that the partial with respect to m, with respect to x, and with respect to y, in both cases are continuous. So this means that the first partials are continuous. Let's see, what do you mean first partials or second partials? Yeah, if you take the partial derivative twice, it's called the second partial derivative, right? If you take it 3 times, it's called the third partial derivative. So this just means that the first partial derivatives are continuous. So if you're ever reading a math book or you're on the internet on Wikipedia and it says f is continuously differentiable, like what does that mean? Just remember, it means the first partials are continuous. It's also called a C1 function. Extra life knowledge. So C1 functions are functions whose first partial derivatives are continuous. What do you think a C2 function would be then? What do you think? Second partial. What about C3?
Third partial.
What about C infinity? All partials. Yeah, so C infinity functions are functions where all the partial derivatives are continuous. So you could just say, suppose m and n are C1 functions. But anyways, I don't want to derail, but now you know some extra stuff, right? Okay, and here's the test. This is what you want to memorize. So to memorize it, I have to look at this, because that's how I do it. So m dx, so you do del m, del, and then it's the other letter, okay? So there's an x here, so you put a y here. That's how I memorize it. Okay, so it's the other letter, so it's del m, del y equals del n, del, so there's a y here. So what do you think you put here? An x. You know the test now, right? Really cheap trick. That's how I memorize it. So it's the other letter. You can use that on the test too. It's just the other letter, right? If it's written like this, it's del m del y equals del n del x. You just flip them, okay? So if this is true, it's exact and we can solve it. we're done. We can do problems now. So we did it. Almost. We just have to do a problem. But we have 18 minutes and we can actually do a problem. So how do you know to do this on a test? When it's gone. Oh. But when it looks like that, which is when it looks like this, some stuff with dx, some stuff dy equals 0. So check to see if it's exact. Let me see if I can find one that's good. This is 2.4. Let's see. 2.4. Too bad it didn't snow last night, huh? Like this morning when I woke up, it said it was 37 degrees outside. Did it snow here?
It was like 20 overnight, I think.
Was it 20 overnight? Oh, fun, fun. Huh? It was really cold last night. Did you? Yeah. It didn't snow though, I think. No, it didn't. No. I was hoping it would, but it didn't. So, huh? Yeah, super rare. Yeah. Have you all ever seen snow? Or, yeah.
Too much.
Too much. Let's do. Oh, that's a really bad example. No. Why all these bad examples? No. Yeah. Okay. Let's do. Hey, can you? Is it working? Yeah, it's working. Hey, can you read me number 3?
In parentheses, you got 2xy squared minus 6 dx plus in parentheses 2x squared y plus 7 dy.
Thank you. Thank extra credit. No, I'm kidding, but thank you. You don't need it. Not yet. No. Oh, did I upload the extra credit? I did? Okay. Okay. The zombie stuff?
Do you want to throw that in?
Just with the test. Yeah, so I don't lose it. So it's just, yeah.
That 7 is just, the 7y is just a 7.
Oh, like this? It's just a 7? Okay, thank you.
It's just a constant.
Is it a point? Or is it? No.
Yes.
Yes. Point. That's basically.
It's on camera. All right, so let's just keep. I can't appear weak. All right, solution. So whenever it looks like this, whenever it looks like, this one might be really bad because it's crooked, so I'll fix it before my next class. By the way, there's more examples of this. I already posted them on the internet. My night class, the same thing. So if you go to that link and the thing. Okay, so this is your M, and this is your N. So you're taking a test, and it looks like this. It might be exact. Might not be. So if it's not, it's going to be homogeneous. What's that? We'll do that next time. All right? But always check to see if it's exact, right? Like, and if you know it's exact and you can't figure it out, just pretend it is and solve it anyways, right? It's better than giving up. Like let's say you do this and you take the partial derivative wrong and you think it's not exact. Don't quit. That's like 20 points, right? Just pretend it is and, you know. Okay, so we have to do del M, del, and what letter goes here? What variable? Do you remember it? Y! Yes! Del M, that's the other letter, right? Good. So let's see. So it'll just be 12, right? Because the 2x is a constant. So 12x y, right? 12xy, right? Because 2 times 6x is 12x. The x is a constant, right? Taking the partial with respect.
It should be
That's
4.
4. Where'd you get the,
Okay, that's points. That's points. Yeah, who got that? Just the whole class. All right. Yeah, it's too many. Does anyone? Can I borrow a pencil? I don't have a pencil. Thanks, Trent. So, all right. So whole class has a point. Oh, here it is. Ryan. Who's Ryan? You have a point from last time, right? Okay. And then all has a point. Thank you, Trent. That's good. Good work. Thank you. I was like, why is she confused? I could tell you were confused. I'm like, it's 12. I'm like, no, I'm wrong. 4xy, and that's 0. Okay, now we got to do del N.
you were looking at the 6 there.
Huh?
You were looking at the 6 there. That's what it was.
Oh, yes, Duncan. My mind is falling apart. Yes, 6 times 2 is 12. So del N del x, same thing. That's going to be 4xy, right? 4xy. So is it exact? Yes. So you just say exact. So yes, exact. On your exam, if you look at the old exam I uploaded, there's a couple questions where all you have to do is this. You just do this and you say yes or you say no. They're just to help you relax during the test. So you'll have a couple where this is all you do. Okay, so it's exact. So what does that mean? So I'm gonna write down what it means up here. It basically means Do you all know the symbol for there exists in mathematics? Do you know that symbol? I'll show you.
Oh, really?
No, it's a backwards E. So this means, you don't have to write this down. This means there exists a function f, such that the total differential, I wish I was taller. Wish I was a little bit taller. Such that that's true. So there exists a function f such that the total differential of the function is this differential equation. So that means that this is del f del x, and that this is, I'm just explaining it so that you understand the next step. And this is del f del y. So whenever it's exact, there is some magical function in the world, we don't know what it is, and such that this is true. So this is del f del x, and this is del f del y. Okay. All right, so now we're going to solve it. How? I'm just going to copy paste it, but actually write it down. So I'm going to write it down again. I'm just going to write it down again, the same problem. So 2x y squared minus 6 dx plus, and this method, by the way, I learned from a student. I used to not do it this way, and many years ago, I had a tutor for this class. And he's like, oh, let's just do it like this. And he did it like in like 30 seconds, and everyone's like, oh! And I'm like, oh, I don't like his way. I'm like, it was like a big thing, and eventually I have gone to his way, the dark side. Okay, so this is del f del x. So all you do now, okay, is you integrate this with respect to x. So there's an x, so integrate with respect to x. I'm going to write it. So integrate with respect to x. Okay, just integrate with, if it's hard, you write the integral symbol if you need to, right? Like if it's a hard integral. But this is really easy, right? So when we're integrating with respect to x, all of the y's are constants, right? So it'll be 2x squared over 2. So the 2's will cancel, right? Right, because it's 2x squared over 2, so it'll be x squared y squared minus 6x, okay? And when you integrate with respect to x, because this is a multivariable function, you have to add an unknown function of the other variable. So we have to add g of y. So whenever you integrate with respect to x, you add a function of y. If you integrate with respect to y, you add a function of x.
And that's the equivalent of like adding a constant.
Right. Very good, Kyle. And if you were to check your work by differentiating with respect to x, this derivative is 0, right? So there's infinitely many pure functions of y. It's a constant function of y, right? Like when you differentiate, the c goes away. If we differentiate with respect to y, or with respect to x, game over, right? It goes away, right? Because we integrate with respect to x. So you differentiate the check. So this derivative is 0. Then you put an equal sign. You might say, why? This is f. This is f, right? This is del f del x. We integrate. This is the answer. We just have to figure out what g is, right? Now we integrate this one with respect to y. So integrate. I think we'll have time to do another example after this. With respect to y. We'll just have to do an easy one. So integrating with respect to y. So this is a constant, so we'll get y squared over 2. So we'll get x squared y squared plus 7y plus, I can't use f's, and I can't use g, so how about h for hard? H of, what there? X. This is in Calc 3, but you barely talk about it. I teach Calc 3, and I barely talk about it. I do one example. There's only one homework problem in the whole course that's available that lets you do this. So you don't get that much practice with it. We're almost done. The next step is to write the answer down. So you check to see if it's exact. If it is, it means there is some unknown function f such that this is del f del x, this is del f del y. So this is equal to f. This is f. This is equal to f. So we're saying f is equal to f. It's like, duh. So we just have to use matching. So how do you do it? First, let me show you how to do it, and then I'll explain it. So how do you get the answer? You write it down. You write it down. Ignore it. Then you look over here. Did you write this down already? Yes, you did. So you don't write it down again. So did you write this down already? Nope. So you write it down. And then it's equal to c, and you're done. And I'll explain that again. I'll explain it again in a second. It's confusing. I'll explain it again. It's a little bit weird. So you write it down, you write it down, you ignore it. Did you already write it down? Yep. So ignore it. Did you write it down? Nope. Why does that work? Because this is equal to this. The negative 6x is equal to h of x. And the 7y is equal to g of y, right? These are equal. These are both the same thing. This is f of xy equals c. This is f of xy. This is f, this is f, this is f. They're all the same. You're just picking what you want from each to get all of it, right? To get all of it. The way to do it is just write it down, ignore it. If it's written down already, you don't write it down twice, basically, right? So if it's already written down, you don't write it. Let's do another one. Let's do one more. How about, let's do number 1. Let's do number 1, just because we have time. We have 7 minutes. We can do another one. Number 1. Oh, on top of it, Nikki.
X minus 1 dx plus parentheses 7y plus 9 dy.
Thank you. Equals 0. Imagine if we had this class like 7 days a week. Like how good you would be at DE. Warriors. Okay, solution. It's like we only have 5 minutes. It's like, wish I had, well, 7 minutes. Wish we had like 3 hours. So you call this M, and you call this N. So then you do del M, del, what letter do you remember? Y, good, del and del Y. Yes, and that's, what is del and del Y in this case? 0. Yeah, they all go away, right, because there's no Y's, right? It's all constants. Yeah, beautiful. And then del n del X is also equal to 0. So it's exact, right? So it's exact. All right, let's finish it. I think we can finish it here. Let's just do it here. Let's just finish the problem. So now we just take this one and we integrate with respect to x, right? So integrate this with respect to x. So we'll get 2x squared over 2. So it'll be x squared. Yeah, because the 2's cancel, right? 2x squared over 2, x squared minus x plus h of what in this case? Y. H of y. Why did I call it h? I have no idea. I could have called, I called it g before. Just whatever. You do whatever you want. Just don't call it f, right? Well, I guess you could call it f, right? We never specified f, so who cares? And this is equal to, and then integrate this one with respect to y. So just, it's whatever is here tells you what to integrate with respect to, right? With respect to x, with respect to y. So it'll be 7y squared over 2 plus 9y plus g of what variable this time? X. Now we can write the answer down, right? So it's x squared minus x. Oh, we don't have that written down yet, right? So we have to write it down. So plus 7y squared over 2. We don't have that written down, so we write it down. Plus 9y. And what's the last thing? Do you remember you said equal to? 0. C. That's it. That's it. It's really easy. This is the easy way to do it. The hard way is to like rewrite everything, rewrite that condition I wrote, differentiate 1, integrate 1. We still have 5 minutes. Maybe we should do one more. You want to do one more? Let's do one more. We got this. We can do it. Look how quick. That took 3 minutes. That's amazing. See, I'm glad I've given in to the dark side. Any questions on this one? All right, number 2. Let's do it.
Quick question.
Yeah.
Does it matter if we have g of x or g of y?
No. Nah, you can use anything. Just name them something else. Can anyone read me? Oh, Nikki. Can Nikki read me number 2, please?
Parentheses 7x plus 6y dx plus parentheses 6x minus 8y cubed dy.
I'd say you should try, but we only have 5 minutes, so then I'll never be able to do it. So, so we should just do it. So let's see. So that's the question. This is number 2. There's some that have like harder integrals, like there's an arctangent or something in the homework, but I just figured I didn't want to push it with how much time we have. So first thing you do is check to see if it's exact, right? So you call this M, You call this n. So you do del m, del y. I hope it's exact. So del m, del y is going to be 6, right? Because this is 0 and this is 6, so it's 6. Good. So now we have to do this one, right? Del n, del x. So del n, del x is also 6, right? Because this is 0, this is 6, right? This is 0 because it's a constant, right? Any questions on the partial derivatives? Okay. Oh, so it's exact. So exact. So exact. So it's exact in this case. Beautiful. Exactly. Yes, Duncan. Always think of, never mind. I'm not going to do it. I'm not going to say it. Do you know what I was going to say? When I say your name, I think of, yeah, okay. Okay, so then, I'm sure you've heard it before. So it's, yeah, like, it's going to be like the plague. Okay, so you take this and you integrate with respect to what? You all know? X, yeah, with respect to x. So it would be 7x squared over 2 plus 6xy plus g of y, right? Because we integrated with respect to x, you had an unknown function of the other variable, and this is equal to. Now you integrate this one with respect to y. Very good. So it'd be 6xy. Ooh. It'd be y to the 4th over 4, right? So it's going to be 2y to the 4th plus h of x. Yeah. Exact is great. So when you know it's exact, you're going to feel like a champion. Always check to see if it's exact. If it's not exact, it'll be something called homogeneous probably, which we'll do next time, right? So the homos are the hardest ones. Like they're super tough. It's always better when it's exact. You can solve it like, I mean, this is great. Let's go to the answer. 7x squared over 2. Yeah, 2.5 is no joke. So I'm really glad we did this today. Plus 6xy. Oh, I got confused. We already wrote it down once, right? So we don't have to write it again. Write it down. What's missing? Equals C. I know it's that weird part, right? The equals C. And that's it. That's amazing that we did 3 problems and we still have 50 seconds. Any questions? Any questions?